On our previous video, we looked at the Lewis structure of neutral carbon compounds, and we were able to account for not only the bonding pairs but also the lone pairs that contributes to the overall structure of a specific compound. Now in this particular video, we're going to look at formal charge and how this particular formal charge is actually important in actually determining the charge of atoms that contributes to the overall charge of a Lewis structure compound. So in this case, what is formal charge? Formal charge is accounting for the number of valence electrons, which is the total in a specific atom, and once you're able to account for that, then you minus half of the number of shared electrons around that particular atom, and also minus the number of unshared electrons, which are mainly most likely the lone pairs. So since that's out of the way, let's look at how we can actually apply this to a specific question. Now in this question, it says that we should draw the Lewis structure and assign the formal charge of each atom in this particular compound. You notice that this compound right here actually has carbon with 3 hydrogens and 2 nitrogens. So to draw the Lewis structure, we account for the total valence electrons, which is carbon having total number to be 4 electrons. We have 3 hydrogens. In this case, we have a total of 3 electrons, and for nitrogen we have 2 nitrogens, and that gives us 5 times 2, which is 10 electrons. Now take note that since we have a positive charge around that particular compound, which is from this particular charge sign right there, it means that this overall compound must have lost 1 electron. Now that means that we're going to take away 1 valence electron from this particular compound, and that gives us a total of 4 plus 3, 7 plus 10, which is 17 minus 1, 16 electrons. Now these 16 electrons will somehow in some way or fashion contribute to the overall bonding and also lone pair in this particular compound. So in this particular case, since we recognize that carbon has a maximum number of unpaired electrons, it means that carbon will stick out first with 4 unpaired electrons surrounding it, and there we introduce our hydrogen. We have 3 of them. Hydrogen comes in, the second hydrogen comes in here to form a bond, and the last hydrogen here comes in and forms a bond. So now that's out of the way, let's look at the nitrogens. How will the nitrogens in some way or fashion orient themselves in such a way that it's stable in this particular compound? So looking at nitrogen, we actually recognize here that nitrogen usually has 3 bonds in that particular compound with a lone pair. However, what we notice is that when you have 2 nitrogens now bonding to a specific atom, in which in this case carbon, we notice that in here we have 1 bond formed here, we have this one right there, but it will form a bond right there. Let's consider the fact that maybe there is 1 other electron coming in here, another electron coming in here, and another electron coming in here, and another electron coming in here. So that means that for the total electrons involved in bonding, we actually consider it to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So in here we have 14 electrons contributing to bonding, and since 14 electrons is contributing to bonding and we have 16 electrons that are valence, in total the remaining electrons is 2. Now these remaining 2 electrons will be contributed to the lone pair on the most electronegative atom, which in this case is nitrogen. Now since we have 2 nitrogens, we count the octet rule and we see how that actually favors which nitrogen. We notice that we have 1 here, and we have 2, we have 3, 4, 5, 6, 7, 8. That means that this particular nitrogen right here is stable. However, this nitrogen on the other side is not stable. So we put these two electrons on this particular nitrogen. So as a result of that, what we actually get is this stabilization of this particular compound, with one thing missing. And the one thing missing here is the fact that, oh, we are losing actually one electron. So in that case, we will have an overall charge here of +1 because one electron is lost in this process. Now, taking note of this, we actually notice that it's asking for the formal charge on each atom. So each atom here, for example, carbon, let's start off here. We recognize that carbon here actually has 4 valence electrons, and since it has 4 valence electrons, we subtract it from half of the number of electrons involved in bonding, which in this case is 8. So since you notice that also carbon doesn't have any form of lone pair, then it means that the total formal charge on carbon here equals to 0. Hydrogen, in this other case, we have hydrogen to have 1 valence electron, which means that the total bonding electrons 2 divided by 2, and that gives us 0. However, for nitrogen, let's make this nitrogen A and nitrogen B. So for nitrogen A, we notice that in this case, this is not sodium, please. We're just labeling as nitrogen A, or we just change it to nitrogen I, which is nickel. So don't consider or confuse nickel with I. Well, you will just go with A for now, or we just put a star. Yes, that's a better labeling. We'll make this a star, and we'll make this double star. So in this case, what I'll do is to erase our A label and our B label, and we just make this a nitrogen star right there. That is much better. So for the formal charge on the first nitrogen, what we notice is that we have 1, which is 5 valence electrons, subtract the total bonding is equals to 8 electrons divided by 2 with no lone pair. That gives us a total of +1. And then for the other nitrogen right here, what we notice is that for nitrogen double star, in this case, we have the valence electron to be 5, subtract 1, 2, 3, 4, 5, 6, 6 divided by 2, minus the number of lone pair, which is equals to 2 electrons. So in this case, this is 3, 5 minus 3 minus 2 gives us 0. So in this particular case, we recognize that the positive charge on the whole compound is mainly coming from the nitrogen at the center. So in this case, our formal charge compound will have a nitrogen plus at the center for specificity purposes, and that actually leads us to this particular structure right there. So that's about it for this particular video. I can give you a challenging question, which is, well, just determine the formal charge on this particular compound right there. You can actually tell us where the specific negative charges are on this sulfate compound right here, which is a polyatomic ion. So all the same, stay smart and believe in yourself.